Hello and welcome to a special edition of Cracking the Cryptic, where I'm going to be taking on this Phistomefel Star Battle puzzle. As canvassed on the channel, this is an absolute treat for me to get to solve a Star Battle puzzle by Phistomefel. I don't think there are. I think this is the only one. I certainly am not aware that he's published one of these before. At least I don't think I'm aware of it. So it should be an absolute treat. And if you're watching this, of course, you're a patron of the channel. So sincerely from Mark and I, thank you so much. Thank you so much for supporting us. It does make a huge difference. Now, what are the rules of Star Battle? Well, it's one of these beautiful puzzles in that the rule set is incredibly simple. What we have to do is to put 2 stars into each row, column, and funny-shaped region. But we have to do it in such a way that the stars don't touch each other, even diagonally. Now, if you're in Penper, which is the interface that we're using today to solve this, if you click Composite, I think it is, and then Object, there's a Star Battle option there. If you click Star Battle, when you go in the grid, you can create stars, and if you looks like double click makes an X. So what we mustn't do is to have that sort of arrangement, because these stars do touch each other diagonally. That's not allowed. Apart from that, there are no other rules, which is one of the beauties of the puzzle. So do have a go first, as usual, and with that, let's get cracking. Now, I love Star Battle, so I really hope I'm going to be able to solve this relatively efficiently. Row 1 of the grid. We know it's got to have 2 stars in it, but this region that's sort of going around the perimeter here, well, if the 2 stars in that region have to be in row 1, we can't put stars down the left-hand side. To do so would mean we couldn't put 2 stars in row 1, which would break the puzzle. So now look at column 1. We need to put 2 stars in column 1. Well, we can't put 2 stars adjacent to each other, so there must be 1 star in this region and 1 star here. Now, actually, what I do like to do in star battles is if I locate a star has to be in a domino or a little region, I like to shade it in a different colour, just to keep track of, where my stars definitely are. Now, this domino means we can't actually have a star in either of these 2 squares, because whichever one of these is the real star, as we can't touch a star diagonally to it, those must both be X's. And I suppose that brings us on to the most important principle of Star Battle, which is that any 2x2 region of the grid can have a maximum of 1 star in it. It is so important to remember that. Now, let's keep going with trying to spot interesting stuff. We can... okay, so there are certain squares that are therefore weak. If we try and put a star in there, you can see that because we'd have to X all around it, where could we put 2 stars in this region now? Well, using our principle that you can only put 1 star in a 2x2 region, this region at the bottom of the grid here can have a maximum of 1 star in it, and that's not enough. So, oh goodness, now I need to unwind all this. So that means this square has to be an X, it can't be a star. Same is true of this square. Look, if this square is a star, we'd rule out too much of this region, so that's an X. There's probably loads of these cells in the grid, but sometimes it can be hard to see them. No, I'm not seeing much. I'm really not seeing much, actually. Now, now, I'm just wondering, actually, Phistomefel being Phistomefel, it is... okay, I think there might be something going on here, because look at what Phistomefel has done with column 1 and row 1 of the grid. He's basically removed them from the puzzle at this point, in the sense that they were given to us very early, and essentially the rest of the puzzle is all but a 10 by 10. Now that should ring bells because we've been talking about 2x2 boxes, and one thing I know about a 10x10 star battle is that I can divide it into a checkerboard of 2x2 boxes. So why don't in fact we do that just to take a look at it. So this 10x10 we can create a checkerboard pattern, and sometimes this can be a really nice way of spotting restrictions in the grid. So let's try and keep this, let's do this reasonably swiftly. There you go. Shall I do the other ones as well? Why not? Let's make those green. Create a very pretty pattern. So what we're trying to do now is overlay in our minds the weird shapes in the grid with these 2x2s and see if we can spot regions which are almost at the bottom here. You can see that this shape here where I'm moving the cursor that's 2 complete regions of the star battle, so it must contain exactly 4 stars, and there is 1, 2, 3, 4 2x2 boxes, but then this annoying square. So if this annoying square was not a star, we would know that the other 2x2 boxes in this shape have to contain stars, but rather annoyingly this square is ruining our pattern. Hang on a moment, let's try and... There's something going on at the top as well, isn't there? Look at... 1, 2... Oh, actually there is definitely something going on at the top. Let's do a count. So what I'm thinking about is if I move the cursor around so if we draw the cursor line from here down to here, and then around this shape up to here, across this shape, right down whatever column that is of the grid, and then snipping out that cell there, how many complete regions of the star battle are involved in that pattern? Well, 1, 2, 3, 4, 5. So that's 5 complete regions of the star battle. So how many stars would be in 5 complete regions of the star battle? 10, because each must contain 2 stars. But how many 2x2 boxes have we got in here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, it's very close. Yeah, this is... Right, okay, I now do understand how to at least start this puzzle, and it is very hard but very beautiful. So we've found... In fact, it's going to help with this square as well. We've got 11 2x2s within those 5 regions. Now, let's ask the question, is it possible that every single 2x2 in these 2 rows, rows 2 and row 3, contain a star? Well, obviously it's not. If I put 5 stars in rows 2 and 3, that's too many. There must only be 4 stars. So exactly one of these 2x2 regions has not got a star in it. Well, let's ask the same question in column 10 and 11 then. How many of these 2x2 regions contain a star? Well, there are 5 2x2 boxes, so we simply cannot put a star in each of them. We'd have too many stars in the columns. So again, one of these 2x2 regions must not contain a star. But we know that we're only going to miss one 2x2 box because there are 10 stars we've got to place and 11 2x2 boxes. So I have to remove the same 2x2 box from rows 2 and 3 and columns 10 and 11 in order to give myself enough space to still put my 10 stars in. So this box here does not have any stars in it. And of course this square here, we know we've got to put 10 stars in these 5 regions. So if I was to try and put a star here, it's now impossible for me to put 10 stars in the region. We can prove that to ourselves. So let's think about it. Now we've put our star in this region, so there can't be any more. So there could be 1, 2, 3, 4, 5, 6, 7, 8, 9 stars in those 5 regions. That's not enough. So this square, of course, is an X. Now, is this helpful? That's the question. Yes, it is. It's helpful in column 10 and 11 immediately, because look at the bottom shape here. We know there's a star in this sort of triomino, and we know there's a star in this 2x2. So that actually deals entirely with the 2 stars that we know are in this shape. So there are no stars in any of those positions. Now we know there's a star in this 2x2, so that's a star. And now we're off to the races, aren't we? Now, and we know there's a star in this 2x2, so that's a star. Now we've got 2 stars in this region that we've already put them in, so that's not a star. We know that this green region has a star in it, so there's no star there and there. That gives us a star here. We know there's a star in this green region, so there's no star in either of those, which plonks a star here. We need a second star in this region. It can only go there, and look at that. That's going to give us 2 stars in row 2, so that's not a star. We need a second star in row 3, so that's a star. There can't be any more stars, look, in column 10, so those aren't stars. This can't be a star because we know the 2 stars in column 11 are in these 2 cells, or these 4 cells, I should say. Okay, so now again we're going to have to think. Yeah, let's have a look at this region. We know there's a star in one of those 2 squares, so there's no star in those 2 positions. Now this is gorgeous. This is gorgeous. So now I want to come back to this region I looked at right at the start here. Because with this X being placed, I now know that each of these regions in these 2 shapes has to have a star in it. Now why does that matter? Well, it matters because look at row 10 and 11. This domino contains 1 star. This domino contains a second star, and this 2x2 contains a star, and this 2x2 contains a star. That is 4 stars, so there are no stars in any of those cells. So now this can't be a star, or it would ruin too much of this region here. Hang on. Yeah, okay, now look at column 2 and column 3. I need to put 4 stars in this column. How do I do that? 1, there must be 1 in this domino. 2, so there must be 2 stars in this 6-cell region here. Now, given the stars can't touch each other diagonally, there can't be stars here and here, therefore. Now, is that useful? So I think what I'm going to do now is I'm going to do some more shading. I want to keep track of these dominoes. So that's a star, that's a star, that's a star. There's a star in one of those for certain. There is a star in one of these for certain, one of these for certain. And we'll switch to... what colour shall I use? Yellow? There's definitely a star in there, definitely a star in there. There's definitely a star. Look, we need 4 stars in column 4 and 5, so there must be a star in this 2x2. There must be a star here. There must be a star here. Right, so have a look at row 8 and 9. I've got 4 stars identified, so this 2x2 region has no star in it. Now look at column 9 of the grid. I need to put 2 stars in it. That must be a star. There must be a star in this domino here, so there's no star next to it. a little bit of a point that comes up occasionally is, could this square be a star? Well, the answer is no, because it would rule a star out from all three of those positions in this row, and now we could only put one star in the row. So we can say with certainty this square is an X. Similarly, actually, look at this. Oh no, that doesn't work. I was about to say this couldn't be a star. But that's not true. Why is this one in blue? I'm not sure why that's blue. I mean, actually, it can't be a star because of the effect it has on this region. If this was a star, all of those three would be not stars, and then I could only put one star in that region. I just can't remember why I put that in and why it's in a different colour. But it's correct. So well done me. Now, what can we do next to finish this off? I think we're on the this square, look, can't be a star. Same reason, it would rule 3 cells out from row 4 and break it. 1, 2, 3. This can't be a star. Oh, that's quite an interesting cell to not be a star. Again, that breaks row 8 of the grid if that's a star, because it rules a star out of all 3 of these cells. But once you make this not a star, where do we put our 2 stars in this region? Look. Well, we can't have a star here anymore. So this domino has a star in it, and this domino has a star in it. And that means we've located, in effect, our 4 stars. Oh, we've done a lot better than that, actually. I'm going to shade it to show you. As we know there is a star in that region there, we've actually got 2 dominoes, look, in row 5 of the grid. So we're going to be able to rule the star out from this square. We know there's a star in this grey region, so there's no star here. There's no star here. We've got our 2 stars in this row. And we're quite close to cracking the puzzle. Come on, let's finish it off. This can't be a star. It would rule 3 stars out of that region. We know that there's a star in this domino. That's the second star, look, along here. So again, we can remove a star from there. We know this yellow region has a star in it, so there is no star here. Oh, it must be about to tumble. Tumble puzzle. Ah, what's the last step? I literally think it must be a last step as well, because it does feel like it should be right on the cusp of falling here. I just can't quite see what the last step is. Oh no, it's not that. I thought I spotted it, but I haven't. Oh, goodness me. No, I can't spot it. Wow, maybe there's another bit of logic we need to find. Let's just carefully count what we've done. So this is all good, this is all good, this is fine. Ah, that's interesting, look. Here's something interesting, yeah. You have to study this region at the bottom here, this sort of backward Z or 2-shaped region. Now this region has got to have 2 stars in it. So if this square was a star, it could no longer have 2 stars in it, because you'd have to cram those 2 stars into 2 adjacent cells. So this is not a star. Now that means, or one of the other consequences of this, is that this domino here has to contain a star in order to get 2 stars in the 2-shaped region. So that means that is not a star, and we've actually located now are 2 stars in row 9 of the grid, which means that's not a star, that's not a star, which means this is a star. Now there must be a star in this yellow domino, so this is not a star. There must be a star here, so this is not a star. We've got 2 stars in this column. And maybe, yeah, look, I think this is starting to crack now. This is one of the features of star battles, is once you get on a little roll, lots of exciting things can happen. We need a second star in this row, good grief, so that becomes a star, yes. So now that becomes a star. We've got 2 stars in this column, so those aren't stars, which means we place stars here. We must X out those. We need 2 stars in this column. They've got to be there and there. And we're nearly there. We've got 2 stars in the bottom row. They turn that, and that is the finished puzzle. I think there are 2 stars in every row. None of the stars seem to be touching each other. It's a beauty, isn't it? I mean, how clever is that star battle? That was not straightforward at all. But, of course, with Phistomefel, it's utterly beautiful. So I hope you enjoyed me struggle a bit with the finish there, but we found some good logic on the way. And thanks again for being patrons of the channel. See you soon on Cracking the Cryptic.